Okay. All right. So in this presentation, I will show a couple of packages that I have that are twin packages for Flux and Lux that provide some recurrent layers, some additional recurrent layers to the offering that these libraries already provide. But first of all, I have the slides. It's going to be a quick presentation, but if you want to follow, you can follow on the Google Slides here. Hopefully, it's just viewing and not also modifying. And but going to the presentation, why are we interested in? So what are RNNs? And in a very simple manner, we can say that RNNs are deep learning models that essentially are a function of the previous time step, previous internal time step, and the current input. So this way they have what's called like an internal memory and a working internal memory that allows them to have to know what the past evolution of the current data looks like. So they can have this working dynamic memory that can be that's replaced at every time step and keeps the memory again of what's been going on in the past. And this is the most simplistic way, of course. We'll go into more detail later on. But the question that everybody is machine learning in the audience will probably have for me is like, why RNNs? Didn't Transformer eat an RNN's lunch like 7 years ago or something? And while this is true for some applications, for others, the RNNs have a better inductive bias for temporal sequences. While since they have this internal memory, they can better express temporal dependencies in time series, for example. In neurosciences, they've been used a lot. They continue to be used. This is a paper for 2024 for rainfall, for example, runoff. And also they are faster at inference time. So transformers have the parallelization going for them since they don't have this time dependency. RNNs have, so they're kind of slower to train. But once they're trained, they can give you the predictions faster. And during the past few years, all the variations of RNNs have been given in the literature. Here I have some examples. There's just a bunch of them. I'm not going to go into them. But as you can see, it's a lot of them. And the issue is that all of these change at a structural level. So it's not you can't simply go into a deep learning library, take the layers that are there, and combine them, because these actually provide new computational time steps from scratch. So you have to go and actually build them yourself, right? And also since transformers, as I said, were proposed in 2017, and PyTorch also apparently came out in 2016, 2017, the progress of RNNs is not well represented because the focus has kind of shifted from what was interesting at the time, so RNNs, to what was hot at the time, so transformers. So the shift happened at the same time, and it's been kind of hard for deep learning libraries to keep track of that. So as I said before, if you want to have these new implementations, you have to implement it yourself, and that's exactly what I did for Lux and Flux. I don't have much fantasy for the logos there, but essentially what's going on in these identical libraries is that they provide additional layers for all of these new recurrent neural networks we saw before in a very simple way, and you can combine them identically, use them identically as you would with the layers that are already there in Flux and Lux. And the structure follows like a very basic pattern. Of course, we have the cells, so these are the most basic layer computation that compute one time step at a time. Then we have the layers. They compute multiple time steps. So essentially, they do the for loop for you of the cells. Life is made a bit easier there. And wrappers that wrap essentially either cells or layers and provide more complicated computation. For example, you can think of PyTorch LSTMs. They also give you a dropout. That's what the wrappers do. I was here actually. Whatever. I have also a full collection of the layers on the other monitor, but time constraints will not let me show it. But to go to how these layers are structured, here we can see a comparison between Fluxes.jl LSTMs on the left side and RecurrentLayers.jl people LSTM cell on the right side. And here, of course, there are easy drop-in replacements, but there are some additional things that you can change. You can change whatever bias you want. You can change the initializers, as you can, of course, on Flux.jl. But more specifically, you can also change what is called independent recurrence and integration mode. So these are two modifications that change how the data is transmitted through the system, through the network. So here we get the addition. This is the most basic way that RNNs are implemented, and almost all RNNs have this somewhere in their forward mode. This is the official way to do it, right? So this is how it was proposed. And but if you want to have multiplicative integration, for example, instead of adding the multiplication of the internal layer in the internal state with the input data, you multiply them. So, and you can do this not for just one specific ad hoc architecture, but for all architectures provided by the libraries. And there's like more than 30 of them at the moment. And then if you want to have independent recurrence, there was also another application done, I think, in 2017. Instead of having the internal state multiplication done with the matrices, you can use a vector. So you have some benefits that come with that. For example, it's faster and, of course, it occupies less memory. And again, this was proposed for the normal RNN, but now you can use, and then another paper showed that you can do it for the LSTM, but now you can do it for all the architectures that are on RecurrentLayers.jl and LuxRecurrentLayers. Actually, with Lux, not yet, but it will be done in the future. And so the future directions at the moment are very simple. Of course, better testing will be always, it's always something that I look for. Better documentation at the moment is really bare bones, it's just APIs. But what I really want to look for is unified and centralized benchmarking. So all these papers usually show benchmark against some models and some benchmark with very specific hyperparameters. So my idea would be to provide all of them for all of the architectures. That's very utopic, but hopefully I'll be able to do it. Additional layers, I want to reach at least 50 by the end of the year, so we'll see how that goes. And in the future, also new ways to train them, because that's also something that's really complicated. I haven't touched upon because the time is what it is. But there are different ways to train RNNs out there scattered in the literature. My idea would be to gather them all in these libraries. And if you want to go look at them, give some support and try them, here they are, the Lux and the Lux and the Flux versions. They go separate ways, so the things that are available in one are not available in the other, and vice versa. So bear with me. Writing in one library is difficult. Two at the same time is even more. But that's all. And if you have any questions, I'm here.
You might have been able to guess what my question would be too. Do you plan on categorizing all the continuous time recurrent layers as well, and handling those?
Yeah, that was the plan as well. It's in the plans. Yeah.
Alrighty.
Any other questions? If not, I do have one, especially to not necessarily to criticize one library or another, but more to guide perhaps the beginners in the audience. Since you've been working with both Flux and Lux, what were maybe the challenges or upsides of each one, and why do you keep maintaining both?
All right, so that's a fantastic question. I would say it will take a long time to discuss the both of them, of course, but I would say that Flux makes things easier at the point in which you can implement them immediately. It's very intuitive to just get there. I think all of them I implemented in a very rapid time. I don't remember the exact timeline, but it was really quick to implement them in Flux. Lux, on the other hand, for example, the testing in Lux is fantastic. Like, it's thorough as much as I can imagine, because it's made available as a separate package to test like Lux layers that way. So performance-wise, I haven't tested it yet, but I would say that, and I actually would paraphrase Chris. I think he said that it's the same tea but with different sugaring or something along these lines. So it's really built on the same things. It's just how different you want to build them. But yeah, I would say that they both are a pleasure to work with in different ways. You just have to look for them, and it depends on how you are as a developer, which one you're gonna like.